So in this video, we are going to learn composite function. We have learned relation. In previous video, we have learned function. Now we'll understand the meaning of composite functions, right? So just observe.
About the composition of functions. Suppose you're at a furniture shop and the shopkeeper is giving a discount of 10% on the purchase of furniture exceeding 5,000 rupees. You purchased furniture worth 8,000 rupees from the shop. Can you calculate the discount that you will get on this purchase? A simple and straightforward approach is to first calculate the amount on which the discount is applicable. This you get on subtracting 5,000 rupees from 8,000 rupees, which gives 3,000 rupees. Next, 10% discount is given on this amount. The discount is 300 rupees. Let us now derive a formula to calculate the discount if a purchase of X rupees is made over 5,000 rupees. In the first step, we have to find the amount applicable for the discount. This we get on subtracting 5,000 from X. Let G be a function from R to R, defined by G of X is equal to X minus 5,000. And then, in the second step, we have to find the discount. Let us define a function f from R to R by f of X is equal to 10% of X. This function will help you to find the discount that a customer gets on the amount exceeding 5,000 rupees. By combining functions f and g, the discount on a purchase of over 5,000 rupees can be calculated. This leads to the definition of composition of functions. If f is a function defined from a to b, and g is a function defined from b to c, then the composition of f and g is a function defined from a to c, denoted by g circle f, and is equal to g of f of x for all x.
So here what we can understand. See, suppose one function a to b and another function g b to c be two functions. Then the composition of f and g denoted by GOF. Okay, g not f is defined as the function that is GOF such that a to c. GOF will be from a to c and given by GOF of x equals to g f x for all x belongs to a. So understood, here two functions. Here f is from a to b and another function g, this is from b to c. Okay, now if you find what is the image of x under GOF, actually GOF is new functions from a to c and it will be defined as g of fx, right? Now
belonging to a. In the above case, the purchase is of 8,000 rupees. So taking x as 8,000 rupees, the composition of g and f at x is equal to 8,000 is equal to f of g of 8,000. Now, g of x is equal to x minus 5,000. Therefore, g of 8,000 is equal to 3,000. Now, f of x is equal to 10% of x. Therefore, f of 3,000 is equal to 10% of 3,000, which is equal to 300 rupees. This is the discount. Some important points to remember while forming a composition of two functions are: if f is a function defined from a to b, and g is a function defined from b to c, then the composition of f and g is a function defined from A to C. The function G circle f is possible only if the range of the function f is the domain of function G.
And this point you will remember.
When G circle f is possible, f circle G may or may not be possible. If both G circle f and f circle G are possible, then they may or may not be equal. Does the composition of two functions f and g in different order affect the result? In other words, does the composition of two functions satisfy commutative law? Let's see. Define functions f and g from R to R such that f of x is equal to 2x and g of x is equal to 3x square. Let's find the composition of functions f and g first, and then g and f. G circle f of x is equal to g of f of x. Substituting the value of f of x, which is equal to 2x, this gives g of 2x. Now, g of x is equal to 3x square. This implies that g of 2x is equal to 3 multiplied by 2x whole square. Hence, the value of g circle f of x is equal to 12x square. Now, let us find the composition of g and f. F circle g of x is equal to f of g of x. Substituting the value of g of x, which is equal to 3x square, this gives f of 3x square. Now, f of x is equal to 2x. This implies f of 3x square is equal to 2 multiplied by 3x square. Hence, the value of f circle g of x is equal to 6x square. Observe that g circle f of x is not equal to f circle g of x. Hence, we can say that two functions g circle f and f circle g are unequal. Hence, we can say, in general, that the composition of functions does not satisfy the commutative property. Let us now prove some important theorems on the composition of functions. If f is a function from a to b and g is a function from b to c, such that both are 1, 1, then the composition of f and g is also 1, 1. Let's recall. When is a function said to be?
So, here one more points is required. That is when we can say a function is invertible function. If gof and fog both same value, gof of x equals to x and fog of y equals to y, then we can say that function is invertible functions. That means if a function is 1, 1 and on 2, okay, right? So now we learn this was the definitions of a composite function. That means let f a to b and g b to c be two functions. Then the composition of f and g denoted by g naught f is defined as the function gof a to c given by gof of x equals to g of fx for all x belongs to a. So these definitions we have to learn. And second things is when we can say a function is invertible functions. That means here one more things we have to find, that is inverse of a function. This part, this is very important part, because generally we are getting in examination inverse of a functions. So this I am explaining, right? Okay, so a function f x to y is defined to be invertible if there exists a function g y to x such that gof equals to ix and fog equals to iy. That means identity functions if you will get. That means gof of x equals to x we have to get, and fog of y equals to y we have to get. Then function g is called inverse of f and it is denoted by f inverse. In another word, if f is invertible, then f must be 1 1 and onto. And conversely, if f is 1 1 and onto, then f must be invertible. That means sometimes we'll use this concept. We'll prove it is 1 1 and onto or not. Okay. If a function is 1 1 also and onto also, then we can find the inverse of the functions. Okay. So Prince understood this.
Yes, sir.
So two things important. Number one, composite of a functions. So composite functions means mixture of two functions. First function will be from A to B. Second function from B to C. Then from A to C will be gof. Now define as gof of x equals to, okay, g of fx. Like that we can find the image of element of A, okay, under gof. Now second things, always gof and fog will not be equal. If gof of x equals to identity functions, if you will get, that means gof of x equals to x is the identity function, and fog of y equals to y if you will get, then we can say that function is invertible and we can find inverse. Another method also we can apply. If a function is 1 1 and function is onto, then also we can say function is invertible function and we can find inverse. So these two concepts we'll use here. So first some questions we'll do. Exercise 1.3, answer 1. Here f is given, g also given. Two functions are given by f equals to this, g equals to this. Write down gof. So we have to write gof. So here f equals to 1 2 3 5 4 1 and g is 1 3, then 2 3 5 1. So we have to find gof. So with the help of diagram I am explaining this. Suppose this is for function f and this is for function g. Okay, so f, this set is 1 3 4 and this set is 1 2 5 and this set is 1 3. That means here elements are 1 3 4, here 1 2 5, here 1 3. Okay, under f, image of 1 is 2. So image of 1 is so image of 1 is 2 and image of 3 is 5 and image of 4 is 1. Then under G, image of 1 is 3, 2 is 3, and 5 is 1. Okay. Now write the answer. We have to find GOF. No? So GOF means from here to here function. GOF A to C. Now GOF of 1. So it is G of F1. So what is the value of F1? F1 is 2. Now under G, G2 equals to 3. So GOF of 1 we are getting 3. Now GOF of 3 find. This is G of F3. So here F3 is 5. Now, F3 is 5. Now G5 is 1. So GOF of 3 will be 1. And last one is GOF of 4. Means G of F4. Now F4 is 1 and G1 is 3. So GOF of 1 we are getting 3, GOF of 3 we are getting 1, and GOF of 4 we are getting 3. Understood?
Yes, sir.
Okay. So write down quickly. Now I'll do question number 3. Now see. Find GOF and fog. Function is given. Number 1. One I am showing, other you will do. Fx equals to mod of x and gx equals to mod of 5x minus 2. Right? Now we have to find GOF of x. GOF means GOF of x we have to find. So it is G of, according to definition, it will be G of fx. Now what is the value of fx, Prince? What is the value of fx?
Sir, mod of x.
Yeah. So here mod of x will write. Now G of anything. That means here definition is gx equals to this. Then in place of x we have to put mod of x. So this mod 5 mod of x minus 2. Then fog of x we have to find. So this is f of gx. Now what is the value of gx? Gx is
Mod of 5x minus 2.
mod of 5x minus 2. Now f of x equals to mod of x, that means it's mod of mod 5x minus 2. So double mod, it is meaningless. So it is 5x minus 2. Mod of 5x minus 2. Okay. So understood?
Yes, sir.
Okay. So each second part you will do, right? Now I'm doing question number 4. Now fx is given. Okay, show that f of x equals to x for all x not equals to 2 by 3. What is the inverse of f? Right. If f of x equals to x you will get, then directly you can say its inverse will be fx itself. So fx is given 4x plus 3 divided by 6x minus 4. Now f of x, according to definition, f of
X.
fx. Now fx equals to 4x plus 3 upon 6x minus 4. Then f of this, in place of x will put 4 into 4x plus 3 upon 6x minus 4 plus 3. In denominator 6 into 4x plus 3 upon 6x minus 4 minus 4, and now simplify. So its denominator 6x minus 4, 16x plus 12 plus 18x minus 12, and here denominator 6x minus 4, so 24x plus 18 minus, if we multiply this, 24x plus 16. So these and this will be cancelled. 24x cancel. Here 12 and 12 cancel. 18 plus 16, how much? 34x, and denominator also we are getting 34. 34 cancel. So x will drop. Find the inverse of function f. This minus 1 comma 1 to range f. If we will get f of x equals to x, that means identity functions, then f inverse equals to f itself, right? F of x equals to x, if we will get, then f inverse equals to f, you can write directly.
Okay, sir.
Okay, now next question. Question number 7. Say most important questions. Achha, state with the reason whether the following functions have inverse. Question number 5 also I am showing. Sometime as a 2 marks question they can ask. Okay, in exam as a 2 marks questions you can get number 1. So f 1, 2, 3, 4. 2, 10 with f equals to 1, 10, 2, 10, then 3, 10, 3, 10, and 4, 10. Is it 1, 1 function? See here.
No, sir.
1, 2, 3, 4. All belongs to domain and they are distinct.
Yes, sir.
Okay. So here 1 not equals to 2. But F1 equals to F2. Both we are getting 10. Therefore, F is not 1, 1. If a function is not 1, 1, therefore F is not here. Show the find the here state with the region following function have inverse. So F is not invertible. That means F inverse does not exist. That means if function is not invertible, so prove either it will not be 1, 1 or maybe not on 2. So you can say your function is not invertible. But question number 7. See answer 7. Consider f R to R given by fx equals to 4x plus 3. Show that f is invertible and find inverse of f. In this type of question, you will consider let y equals to fx. Right. So y equals to 4x plus 3. Then 4x equals to y minus 3. Then x equals to y minus 3 upon 4. So this will consider as gy. Gy equals to y minus 3 upon 4. Right. Now check g is inverse of f or not. Okay. So find gof of x. So g of fx. So g of fx is 4x plus 3. Then find g 4x plus 3. In place of y, put 4x plus 3
Minus
minus
3.
3 upon 4, and 3 and 3 cancel. So 4x upon 4 cancel. So this is ix identity function we got. Then find fog of y. So f of gy. So gy we are getting y minus 3 by 4. Now f of y minus 3 upon 4 will be, now put in f, that is 4 into y minus 3 upon 4 plus 3. Then 4 and 4 cancel. Y minus 3 plus 3. Now 3 cancel, and we are getting y. That is IY. Now Gov of x we are getting ix and fog of y we are getting iy. So therefore we can say that f is invertible. And f inverse will be g, where g r to r and gy equals to y minus 3 upon 4. Another method is, and another method also you can use, prove it is 1 1, prove it is on 2. If it is 1 1 and on 2, after that from on 2 you can create one new function g, and that g will be the invertible function. But best way is Gauss and Fogg. Okay, using this method if you are doing, then easily you will get. And most important questions is question number 8, either question number 8 or question number 9. These two questions many time in examinations came. So I'm showing question number 9, and after that I'll end this video, and rest of the questions you will practice. Question number 9 I'm showing. So basically these kind of questions we are getting in exam. So consider f r plus 2 minus 5 comma infinity, and fx is defined as 9x square plus 6x minus 5. Show that f is invertible and f inverse y will be this. So here we'll create one new function. So let y equals to fx, y equals to fx is 9x square plus 6x minus 5. Now we have to find the value of x. So 9x square plus 6x minus 5. Here put bracket plus y we can put equals to 0. Now it is a quadratic equation of x. So use quadratic formula. So x equals to minus b. That means minus 6 plus minus root over b square. So it is 6 square minus 4ac. 4 into 9 into minus 5 plus y upon 2a. 2 into 9. So x equals to minus 6 plus minus 36 plus, here also 36 into 5 plus y. Here 18. Take 36 outside of root. X equals to minus 6 plus minus 6 root over 1 plus 5 plus y divided by 18. Now take 6 common and cut with 18. X equals to, take 6 common. So it is minus 1 plus minus root over 6 plus y upon 18. Now 6 3 18. Since x will be positive, that means r plus, so negative value will ignore. So here x equals to minus 1 plus root over 6 plus y upon 3, since x belongs to r plus, that means real positive. So this value. So this can be written as gy equals to root over 6 plus y minus 1 upon 3. Now we check GOF and FOG. We are getting identity function or not. So first check GOF of x. So GOF of x is g of fx. So it is g of fx is 9x square plus 6x minus 5. Little bit you have to calculate. Then g of this, then in place of y we put here 6, here we put 9 x square plus 6x minus 5 minus 1 upon 3. So definitely it will be a perfect square number. This is 9x square plus 6x plus 1 minus 1, and this is 3x plus 1 whole square. So this is a perfect square number. So it is 3x plus 1 minus 1 upon 3. So 1 and 1 cancel. So 3x upon 3 we are getting, cut it. Then x we are getting, that is ix. So identity we got. Then fog of y. So f of gy. So f of, now gy equals to root over 6 plus y minus 1 upon 3. Then f of this, so 9 into its whole square. So it will be root over 6 plus y minus 1 whole square and divided by 3 square is 9. Okay. Then plus 6 into root over 6 plus y minus 1 upon 3 minus 5. Calculate this. Are you getting y or not? Just check. 9 9 cancel. 3 2 jai 6. So if you will find its square, then it is 6 plus y a square minus 2ab. 2 root 6 plus y plus b square. So 1 plus 2 root over 6 plus y minus 2 minus 5. So clearly these two will be cancelled. 6 plus 1 7 and 6 plus 1 7, and here also 7 can be cancelled. So y, that is iy. If you will get GOF of x equals to ix and fog of y equals to iy, then clearly you can say it is f is, therefore f is invertible. And f inverse will be what? F inverse equals to g, and g what we are getting? That is g equals to root over 6 plus y minus 1 upon
3.
3. Hence true. So I hope you understood this.
Yes, sir.
Okay. And this was the most important question of this exercise. Rest of the questions you will try. So I'll end this video here. Okay. So our this chapter finished. Okay, fine.